I'm here with lecture 4, right? And yesterday I discussed how to find electric field, right? And also I derived formula to find electric field, right? And what is the formula? Formula is electric field is equal to E is equal to KQ by R, right? This is formula to find electric field, right? K is known to you, K is the constant, right? Q is the charge, R square, right? R is the point, R is the distance of that point at which we are going to calculate. R is the distance of that point from the charge at which we are going to calculate electric field, right? So this formula yesterday I derived, right? And today I am going to take one question on this formula, right? One question on this formula and going to find electric field as well as force on charge due to electric field, right? These two things I am going to find, right? So as you see, I have already written the question on the blackboard, right? So what is the question? An electric charge kept at a point A, right? So any point, suppose this is your point A, and I kept a charge Q at this point, okay? And what we have to find? First question is electric field at a distance 3 meter from it, right? Suppose I'm going to find, we have to find what? Electric field at a distance 3 meter from A, right? So this is your A, right? And we have to find electric field at a point, any point suppose, and suppose this is your point, right? And this point is located at what distance? 3 meter, right? This point is located at 3 meter. So this is your R, right? So in question, what value is given? We can write given. What value is given? First I am going to solve question number 1. Given Q is equal to how much? Q is equal to how much? You are able to find Q, right? Electric charge of 5 coulomb. Sorry, I have to write here of electric charge 5 microcoulomb, right? So this is your Q. Electric charge of 5 microcoulomb is kept at a point A, right? So Q is given. How much is the value of Q? 5 microcoulomb. 5 microcoulomb, right? And one more thing is also given. R is given, and R is how much? 3 meter, right? These two things are given, right? And we have to find electric field, right? You know the formula of electric field. E is equal to KQ by R square. KQ by R square. K is known to you, right? And Q is given here, right? But here Q is given into microcoulomb, so we have to convert into SI unit, right? So if I am going to convert it to SI unit, so convert microcoulomb to coulomb, we have to multiply with 10 to the power minus 6. Now this one is converted into coulomb, right? So now I am going to substitute all those values in this formula. So now see, this is your K. K is how much? 9 into 10 to the power 9. And Q is how much? 5 into 10 to the power minus 6. And R is how much? 3. So 3 square. 3 square is how much? 9, right? 3 square is 9. So this 9 is cancelled by this one, right? So finally I got the value 5, and you can see here 10 to the power 9 and 10 into 10 to the power minus 6, right? So power will become 10 to the power 3, right? And this is what electric field. So unit of electric field is Newton per coulomb, right? So this way we are able to find electric field with using this formula, right? With the help of this formula, right? So finally I solved question number 1, right? This is your question number 1. In question number 1 we have to find electric field at a distance 3 meter from point A. So I calculated this value, okay? In second question they are saying that if 5 coulomb charge, if 5 coulomb charge is kept at the same point, if 5 coulomb charge is kept at the same point, then we have to find force on that charge, right? So we have to find force on this charge, right? So I am going to solve second question here, right? So yesterday electric field is defined as, electric field is defined as force per unit charge, yes or no? Electric field is defined as force per unit charge. So from here we can write force is equal to electric field into Q into E. Force is equal to Q into E. Force is equal to Q into E. Right? Now see, for question number 2, this Q is already given in the question. Yes or no? This is your Q. And electric field I already calculated here. Right? So by substituting the value, we are able to calculate force. Right? So now I am writing here F is equal to Q into E. And Q is how much? Given. Q is given how much? 5 coulomb. So I am directly writing here 5 into electric field. I calculated already here 5 into 10 to the power 3. So just we have to substitute that value here. 10 to the power 3 is equal to 5 into 5, 25 into 10 to the power 3. And this is force, so unit will be Newton, right? So with the help of this formula, we are able to calculate electric field, and with the help of this formula, we are able to calculate force on charge, right? In electric field, right? So suppose if electric field is given here and you have to find force, then with the help of this formula, you are able to calculate force on that charge. Okay? So this formula is useful to calculate electric field, and you are able to calculate, right? Okay, so if you want, so just note it down. And next we are going to discuss electric field lines. Okay, right? So electric field lines, right? What is electric field lines, right? So electric field in a region, right? Electric field in a region is represented by drawing certain line, right? Electric field in a region graphically represented by drawing certain lines, right? That line is known as electric field lines. Okay, clear? So what is electric field lines? The electric field in a region, the electric field in a region is the electric field in a region graphically represented by drawing certain line. Okay, so the electric field in a region graphically represented by drawing certain line, right? That line is known as electric field lines, right? That line is known as electric field lines. Okay, that line is known as electric field lines, right? This is imaginary things, right? Nothing is existing like this. Okay, this is just imaginary, right? By drawing line, just we are imagining the electric field, right? Nothing like this is existing. Okay, so somehow you are able to understand, right? So this is your electric field lines, right? And sometimes this is also known as lines of force, right? Okay, so now next we are going to discuss property of electric field lines, right? What are the property of electric field lines? Okay, field lines, properties of electric field lines. Okay, right? So first property, right? First property, right? Property is it originates from positive charge and terminate in negative charge. Okay. So first property originate originate from positive charge and terminate in negative charge, right? Terminate in negative charge. Okay, so this is your first point. So you can see here, suppose this is your positive charge plus Q, right? So electric field lines will originate from this one, right? It is originating like this. Yes or no, right? And similarly you can see that suppose charge is negative minus Q, so electric field lines will terminate on this charge. Okay, so write a statement and draw the figure. Second point, electric field lines do not form closed loop. Okay, so electric field lines do not form closed loop, right? So suppose if sometimes electric field lines is given like this, right? This is not possible, right? This is not possible. Okay, this is not possible because you can see what is the electric field lines do not form closed loop, but here closed loop, right? So it is not possible for electric field lines. Okay, so third point, suppose electric field lines is given, right? So with the help of electric field lines we are able to calculate direction also, right? How? Just see, tangent drawn on electric field lines, electric field line gives direction of electric field, at that point, right? Tangent drawn on electric field lines gives direction of electric field at that point, right? Okay, now you can see, suppose this is your electric field lines. Okay, so this is your electric field lines. Okay, so suppose I am going to find direction of electric field lines at any point, right? So just draw tangent at that point. Suppose this is a point P, right? And at this point we have to find what is the direction of electric field, right? So to find direction of electric field at this point, just draw tangent on this point. That will give you direction of electric field. Okay, so this is your electric field lines, right? So tangent on this point will be somehow along this direction, yes or no, right? So this tangent will give direction of electric field, so this is it, direction of electric field at point P. Similarly, suppose I am taking any other point here, This is point Q, and we are going to draw tangent at this Q point. Then, so if I am going to draw a tangent at this point, it will give direction of electric field at this point, right? So this is also your direction of electric field. Okay. So third point is, by drawing tangent on electric field lines, we are able to find direction of electric field at that point. Okay. So third point. Okay. Third point is already done. Fourth point. Now I am going to write. So see what is your fourth point. So two similar charges. Two similar charge filled lines of one charge get deviated from other charge, right? Okay, for two similar charge, right? For two similar charge, field lines of one charge get deviated from other charge. Okay. So now see, suppose this is your one charge, okay, and this is another charge, right? What is here? Similar charge. Similar charge means both is positive or both is negative, right? So electric field lines of one is deviated by another one, right? So electric field lines is, for this one electric field lines will be like this, plus Q, right? So you can see both is positive, right? So electric field lines is coming out, right? But due to presence of two similar charge, electric field lines is deviating from one another. So see, this is deviating in this direction, right? Okay, and this is also deviating in this direction, right? So for two similar charge, electric field will deviate, right, due to presence of other charge. Okay. So next point, I'm going to write point number 5. Okay. So see what is the point 5. The number of electric field lines originating or terminating the number of electric field lines originating or terminating is directly proportional to magnitude of charge. Right. So number of electric field lines originating or terminating is directly proportional to magnitude of charge, right? If the amount of charge is greater, then electric field lines will originate or terminate more, right? So now you can see here, suppose I am taking two charges here, right? 1, 2, 3, 4, 5, 6. So 6 electric field lines is coming out. Okay. Suppose this is your charge plus Q. This is your charge plus Q1, right? And another charge is also present here. So you can see here how many electric field lines is coming here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you can see here for charge plus Q, 10 number of electric field lines is coming out, right? And but for this one only 6 electric field lines is coming out, right? So according to this point, you are able to see number of electric field lines is originating or terminating directly proportional to magnitude of charge, right? So magnitude of charge. So if here number of electric field lines is more, so charge is greater, right? Similarly here, electric charge is, number of electric field lines is smaller, right? Charge is smaller, right? So we can write here Q1 plus Q1 is smaller than plus Q2. Now see point number 6. Okay. point number, the two electric field lines. The two electric field lines never intersect each other. Never intersect. Two electric field lines never intersect each other. Never intersect each other. Okay, two electric field lines never intersect each other. If this one is going to intersect, suppose this is your one electric field lines, right, and this is another electric field lines. Okay, so at this point these two electric field lines is intersecting, right? So if I am going to draw tangent on this curve, so tangent will come on this direction, tangent will come in this direction, so this tangent will give direction of electric field at this point in this direction, right? But suppose if I am going to draw tangent on this curve, right, so tangent will come in this direction, right? So you can see here at same point two direction of electric field lines is possible. Electric field is possible at same point. Two direction of electric field is possible, which is not correct, right? Which is not correct, right? That's why two electric field lines never intersect each other, because at intersection point, two possible direction, right? Two possible direction. This is not correct, right? This is not correct. Okay. Okay. Now see point number 7, right? So point number 7, right? So what is point number 7? So first I am writing the statement. After that I will explain it. Okay. So parallel. What is that? Parallel, straight, equispaced, parallel, straight, and equispaced electric field lines represent uniform electric field. So parallel, straight, and equispaced, right? That means suppose this is your electric field line. So this kind of electric field lines will represent uniform electric field, right? This kind of electric field lines represent uniform electric field, right? You can see all the electric field lines is straight, right? Straight, and separation between equispaced. Separation between these two lines is also same, right? And parallel, right? So these are known as uniform electric. So these electric field lines represent uniform electric field, right? So this is all about your electric field lines. Okay. So next we are going to discuss electric flux, right? Electric flux, right? Electric flux is represented by phi E, right? Phi for flux, right? And E for electric flux, right? So electric flux. Okay. So what is the electric flux, right? So I already discussed electric field lines, right? So electric flux is number of electric field lines passing through any area is known as electric flux, right? Suppose this is your area, right? This is your area, and this is your electric field lines, right? So this is your electric field lines, this is your area, right? And electric field lines is coming perpendicularly like this, and it will come out like this, right? So electric flux is basically count of number of electric field lines passing through any area perpendicularly, right? Perpendicularly is known as electric flux, right? So we can write here, it is defined as number of electric field lines, number of electric passing. So you can see here Electric flux, it is defined as number of electric field lines passing perpendicularly to a plane surface, right? But how we can calculate the value of electric field lines, right? For that there is a mathematical expression, right? That one now I am going to write, okay? That one now I am going to write. Suppose this is your area, right? Okay, this is your area and electric field lines is passing through this area like this, right? This is area and electric field lines is passing through this area, right? And direction of this area is, and this is your direction of area vector. Area vector I am representing with S, right? So electric flux is defined as, so this is angle between electric field and area vector. Yes or no? This is angle between, this is angle between, this is your area vector, right? And this is theta is angle between electric field and area vector, right? So electric flux, what is the formula of electric flux? So electric flux will be equal to electric flux, right? Electric flux for E is equal to E dot S, E dot S, right? E dot S, okay? So this is formula to find electric flux, right? Where you are able to write E is the electric field, right? Where E is electric field and S is area vector. Okay, I am writing here also, that one also. Where E electric field, E electric field, and S is area vector, right? And this is known to you, right? Electric flux, right? So this way, if electric field is given and area is given, then you are able to find electric flux, okay? So now I am going to write some points related to your electric flux, right? Okay, so note it is a scalar quantity. Second point, unit. Now you can see here electric flux is basically E into S, right? You can see now phi is what? Phi is what? E into S. Yes or no? And unit of E is what? Unit of S is Newton per, unit of S is Newton per Coulomb. Yes or no? Newton per Coulomb. And S is area and unit of area is meter square. Yes or no? So further we can write here unit of electric flux is Newton meter square per Coulomb. This is your unit, right? So unit of electric flux is Newton meter square per Coulomb. Okay. So now I am going to take one example and trying to find electric flux, right? How we can calculate value of electric flux, right? With the help of one example, I am going to understand that one, okay? So, okay, now see, this is a rectangle, right? And area of rectangle is given, right? So here, this is your S, direction of your area vector, right? And electric field is existing like this. Electric field is existing like this, okay? And so this is rectangle, right? Area of rectangle is given, right? So I am writing here given S, right? Given S is equal to 40 meter square, right? Given S equals to 40 meter square, right? And electric field is equal to electric field is equal to 45 Newton per coulomb, right? Electric flux is given, area is given, electric field is given, right? And angle between, so this is your direction of area vector, right? So this is your direction of area vector, right? And electric field is existing in this direction, right? And angle between these two is 60 degree. Angle between electric field and area vector is 60 degree, right? These things are given in the question. Question is written like this, okay? And question is find find electric flux. Find electric flux, right? So you know the formula. How to calculate electric flux? There is a formula, right? So what is formula to find electric flux? Phi E, right? And phi is basically E dot S. So now dot product, you know how to find. What will be the value of this one? Value will be E S cos theta. Yes, cos theta, right? And theta is given. This is your theta, right? E is given, S is given. Just substitute the value, get the answer, okay? So I am substituting the value. So first one is S is 40. I am writing first electric. This is 45. And this is how much? 40. And cos 60. Theta is 60, right? This is your theta, right? So cos 60 degree. Okay. So further we can write 45 into 40 into cos 60 is 1 by 2. These two cancel. 40 divided by 2 is 20, right? 20 multiplied by 45, right? So how much will come? 900, right? 900, right? And unit is known to you, right? Unit is Newton meter square per coulomb. Newton meter square per coulomb. This way you are able to find electric flux, right? Okay. So this way we are able to find electric flux due to uniform electric field. Yes or no? This electric field is uniform, right? Electric field lines is equally spaced and parallel, huh? So finally we calculate electric field due to uniform electric field, right? Okay, so next I am going to calculate electric flux due to non-uniform electric field, right? Electric flux due to non-uniform electric field. Okay, so electric flux due to non-uniform electric field. So electric flux due to non-uniform electric field, right? So just you see this figure. This is your area. I'm taking any random area, right? This is your area, right? And electric flux is passing through this area, okay? Now you can see these are the electric flux. This is passing through this area, right? So here you can see here electric field is not uniform, right? Electric field lines is not parallel, yes or no? Okay, so electric field is not uniform. So to find electric flux through this area, we have to find electric flux through a small area, right? Suppose I consider very small area here. Suppose I consider very small area here. right? So to find electric flux through this complete area, we have to calculate electric flux through a small area, right? And so for this small area, we are able to consider electric field is constant, right? And then by integrating this electric flux, we are able to calculate electric flux through entire area, right? So first I am going to calculate electric flux through this small area, right? Okay. So this is your small area. So this is your direction of a small area, right? And what is area vector? ds, right? And electric field is suppose here electric field is in this direction, right? And that electric field is E, right? So a small electric flux through this small area, right? So first we have to find a small electric field through this small area, and then by integrating that area we are able to calculate total electric flux through this entire area, okay? So first I am calculating a small electric flux through a small area, okay? So I am writing here a small electric flux through a small area, d pi e, and this d pi e is equal to E dot ds. Why I am using this formula? Because for a small area we are able to consider electric field is a uniform, right? So we are able to write this formula, right? So now total electric flux, right? Total electric flux phi e. So total electric flux phi is basically integration of E dot S, okay? E dot S, okay? So this is formula to find, this is formula to calculate electric flux through area in non-uniform electric field, right? Okay, this is all about today's lecture, okay? So in next class I am going to solve one question on this formula, right? Using this formula. So that's all.